Good afternoon, Dr. Z, and today I'm going to be talking about the Clausius Theorem and inequality. So the Clausius inequality applies to any real engine cycle, and the equation for that is the integral of dq over t is less than or equal to 0. And q in this equation is the heat entering the system at any point in the cycle, and t is the temperature at the point of heat entry. So there are some other things that involve the Clausius inequality. One of them is the Carnot cycle. And the equation for the Carnot efficiency is TH minus TC over TH multiplied by 100%. So you're going to get a percentage for that specific equation. So the equal sign in the Clausius inequality above applies only to the ideal or Carnot cycle, which is pretty much the Carnot efficiency. Since the integral represents the net change in entropy in one complete cycle, it attributes a zero entropy change to the most efficient engine cycle. It makes it clear that any entropy does not decrease even in an ideal engine cycle. So pretty much it stays the same, that there's no change. So the Clausius inequality applies to any real engine cycle and gives a negative change in entropy on the cycle. That is, that the entropy given to the environment during the cycle is larger than the entropy transferred to the engine by heat from the hot reservoir. And the hot reservoir, there is the equation. This also goes with the Carnot cycle. So it is W over QH equals QH minus QC over QH. So that's going to give you the efficiency for the maximum for the Carnot cycle. So in the simplified heat engine, where the heat is QH, is all added at temperature TH, then the amount of entropy delta S equals QH divided by TH is added to the system and must be removed to the environment to complete the cycle. In general, the engine temperature will be less than TH for at least part of the time when the heat is being added. And any temperature difference implies an irreversible process. Also, the excess entropy is created in any irreversible process, and therefore more heat must be dumped to the cold reservoir to get rid of this entropy. And this results for less energy to do work. And then there's also another equation for change of entropy. That equation is ds equals dq over t. And the ds equals the change in entropy. So I hope that this sums it up. I hope you stay safe and see you next class.